Good day to you, students. We want to continue from where we stopped. Circuit geometry. I told you it's in series because we have some theorems that we have to talk about. So after this cyclic quadrilateral, that's the fifth theorem. We'll have to check two to three exercises. We check them together. Then we move to tangent. That is another segment of this circle geometry. So what is cyclic quadrilateral? When do we have a cyclic quadrilateral? So when you have a circle, don't forget we are discussing circle, and you have a quadrilateral inside this circle. But the quadrilateral I'm talking about has to have its vertices. Its vertices, for instance, all its vertices at the circumference. All its vertices, the vertices, that is all its coordinates, all its points at the circumference. All its points at the circumference. Let's call this one a B, a C, a D now. So this is a quadrilateral. That means four sides and four angles. So we have all its not this is not when we have this is not a cyclic. This one is we only have three at the circumference. This one is not at the circumference. So we are not talking about something like this. We are referring to something like this. It doesn't matter how it is drawn. It can be very terrible like this. It can be very terrible like this. It can be like this. It doesn't matter. So far you can relate the four corners, I mean the four vertices, and they are at the circumference. That's the hint. You can identify a quadrilateral in a circle, and you can see the four vertices at the circumference. I'm emphasizing at the circumference. There is a cyclic quadrilateral theorem there. And what does it say? It says opposite angles of a cyclic quadrilateral are supplementary. Simple. Supplementary, you know what supplementary means? That means the two angles that add up to be 180 degrees. So you 60, 120, 20, 160, 10, 170. Those are supplementary angles. So this and this are opposite. So if this one is theta, this one will be 180 minus theta. Simple. If this one is 40, automatically this one is 140. That is what we are trying to say. This is what they call cyclic quadrilateral. So all you need to say is, if you have this, then you tell me this one is 180 minus 40, cyclic quadrilateral. That is the theorem. It's so simple. Let's check some exercises. Look at this. Let's see the theorems available here. I have a diameter. So definitely if there is a diameter, I have 90 degrees here. One. I have same segment here and here, same segment. Two. Then I have this one and this one to be cyclic. Three. So if I should get this angle, it is equal to this angle, same segment. So how do I get this angle? I can get this angle. If I get this angle by cyclic quadrilateral, then I can remove it from 90 degrees to get this angle. Then it will be equal to this angle. Then the game is over. Interesting, right? So let's work. Here, this angle, let me call this one y, as the case may be. So let's call this one y. This is also x. So I will say 180 minus 132 is equal to y, or you call it TPQ. Why? What is your reason? Cyclic. Just say cyclic quadrilateral, then you're fine from there. So this one, if you subtract this one from here, you have 48 degrees is equal to y. So this one is 48 degrees. So God so good, we have this one to be 90 degrees. So therefore, we should write it. So TPQ, angle TPQ is equal to 90 degrees. Y, semicircle. Sorry about that. Semicircle. This should be semicircle. So if this is semicircle, then therefore we have 90 minus 48 degrees. That will be 42 degrees. So far we have 42 degrees here. That is 42 degrees. So therefore, x will be equal to 42 degrees. Why? Same segment. That is that. I hope you can understand. Let me explain this again. I have a cyclic quadrilateral here. That means this point, this point, this point, this point. Look at it. It's cyclic quadrilateral. Look at it. It's cyclic quadrilateral. So there is a quadrilateral in the circle. So that have the four are having their vertices at the circumference. So that's why I can relate this one with this. So if I have 32 here, definitely this is 48. And from this diameter, I have a right angle, so definitely this will be 42. So if this is 42, then this is 42 as well. Same segment. Because this one is equal to this will be equal to this. That's all we have there. So I want to let me give you classwork. Try some questions, then we can proceed from there. Look at this. We are solving for x and y. Look at this. I can see a theorem here. Look at it. So this one is related to this. This one is related to this. So check that out. And here, if straight line gives us this, then we can get this one. So if you get this one, it's fine. Then this one and this one, because of the cyclic quadrilateral, this is, you have them 1, 2, 3, and 4 here. This one and this one will be equal to 180 supplementary. So you have that. And here, look at this picture. This one and this one too are cyclic. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if we get x here, then we can get this one from our second theorem that says angle at the center is twice angle at the circumference. So I've given you simple questions. So try them out and let's see what you have.